Welcome back to this channel. This channel now is 160 plus videos. So if you haven't subscribed to this channel, now it's time to do so, so you can have a front seat to enjoy all those videos for your mathematics revision. All right, today we're going to use the polar form of a complex number to solve this question. So we have a, excuse me, we have a complex number called omega. So omega to the power of 3 is 1. And also imaginary component of omega is greater than 0, which is positive. And we also know this polynomial has 3 roots. First is 1, second one is negative omega, and the last one is a negative omega conjugate omega. So we need to determine what is A, B, and C. So basically we need to find out what's that polynomial. So now we're going to solve for 2 things. First, we need to find out what is omega. Secondly, we need to determine what is a negative omega, which is easy. Once you find out omega, you can find out all those 3 roots. So let's do that. So find the omega first. So I'm going to use this formula we call polar form. I'm going to use omega equal to, so we say let omega is r CRS theta. Now, because we know the condition tells us omega to the power 3 is 1. So therefore, r must be 1. So the modulus must be equal to 1. So therefore, omega will be only CRS theta. So we need to find the angle. So that angle we call argument of omega. All right. So let's do that. Let's find the theta, the argument. Now, why are we doing this? So let's try. So first, we know omega to the power 3 is 1. So therefore, omega will be equal to CRS. If omega 3, I'm going to use a conjugate. I'm using the polar form. So it'll be 3 theta. And we know equal to, so if I expanding this, become cosine 3 theta plus I sine theta equal to 1. All right, so that's so I'm going to put I0 times by I. So this is the real component, which match with the real component. All right, so we give us the cosine 3 theta equal to 1. So therefore, we can decide what the theta is. So let's do that. So we know inverse of that function. So 3 theta will be inverse of 1. And that's give us 3 theta we have a more than one answer, so we put a 2 imply. All right, so because n is a positive integer as well as including 0 as well. So it could be equal to 0. So therefore, theta will be 2n pi divided by 3. So I'm going to use a positive integer for this case, including the 0. Now, then we're going to decide exactly what the theta will be, because we can more than answer. So I'm going to choose 3n. First is 0, second one's 1. Next one is 2. Why I choose 3, which I'm going to write down, because this is equal to omega 2 power 3 is 1, so therefore omega has 3 roots. So therefore I'm going to choose theta 1 is 0, and second one is 2, n is 1. Third one is n equal to 2, so which is 4 pi over 3. So I'm choosing 0, 1, 2 for the n. Now then we decided which one is true because we have a condition. The omega, the imaginary component of omega must be positive. Now let's try imaginary component, which is the sine theta, must be positive. Now because we got 3 angles, so therefore we're going to substitute the theta 1 into it. So when the theta equal to 1, sine theta is 0. So that's not a positive. So therefore that one's not right. Next one, I'm going to choose the next one, 2 pi over 3. Sine 2 pi over 3 is 2 pi over 3 is a second quadrant. So it's a positive. Why? Because 2 pi over 3 belongs to second quadrant. Third one, if I choose 4 pi over 3, sine 4 pi over 3 is negative, because 4 pi over 3 belongs to third quadrant. So therefore, we only can choose, now we can't choose this one. So we can't choose this one. So the only theta we can choose is the second one. So therefore, the omega must be only 1 CIS, theta is 2 pi over 3. All right, excuse me. So I'm going to expanding that. All right, let's simplify. Cosine 2 pi over 3 is a pi minus pi over 3. So pi minus pi over 3. So let's finish off. So that's a negative half plus sine pi over 5 is a positive square root 3 divided by 2 I. So that's my omega. All right, we got 3. So now, therefore, we need a second. So negative omega will be positive half minus square root 3 divided by 2. And negative conjugate will be negative plus square root 3 divided by 2. Y, let's do one more step. Negative of negative half, that's conjugate. So if we expand in bracket, become positive and positive. Now, so therefore, the PZ has 3 roots. First one, 1. Three roots at 1, negative omega conjugate. So therefore, we can write the polynomial into 3 brackets because we're according to the roots theory. Second bracket should be z minus, which is that's the next one. Third one is the z minus next one. So it'll be minus 1 plus square root 3 divided by 2i. Okay, we got 3 brackets. So, but we haven't finished yet. We need the ABC. We need expanding the brackets. So what I'll do, I'm going to put z minus 1 into the bracket. So therefore, this will become plus. Next one, I'm do the same. I'm going to put z minus half, then negative root 3 divided by 2. By doing that, you can see I got a squared plus b squared, a plus b. So this is like a plus b. That's a minus b. So I'm going to use a difference of square formula. So to take the bracket off. So it'll be z minus half square minus b square will be this square. Now that's easy. So now we're going to expanding the next bracket, which is this one. Z squared minus z plus 4, 1 over 4. And that one will be positive 3 over 4. Now we're going to put together will be z minus 1, z squared minus z plus 1. So now we're almost there. Now we're going to expand in bracket into cubic function. So that's it. But BPZ is z cubed plus az squared plus bz plus c. So therefore, my a will be negative 2, b will be 2, and c is negative 1. So we solve the question. Take a little while. Take a pretty long step, but it's a complex, unfamiliar question. I hope you enjoy the solution. If you do, please give us thumbs up. I'll see you next video. Bye.